should have finished these 10 questions within less than 20 minutes. Okay. So let's come to the question number 1. Length of rectangular wooden block is measured using Vernier caliper. Figure shows relevant section of the Vernier calipers and the block. If there is no zero error in the Vernier caliper, then the length of the wooden block is. Tarune, first of all, you need to determine least count. Least count of a Vernier caliper is 1 main scale division divided by number of Vernier scale division. Did you see here in this instrument, length of one Vernier division is greater than length of one main division, right? What do you call those types of Vernier scales? Extended Vernier scales. So somehow 1 mm is 1 millimeter. How many Vernier divisions are there? 10 or 20? 10, 10. So this is 0.1 millimeter. Then I need the reading. Pute, 0 of the Vernier is here. Just before 0 of Vernier, what do you have? What is the main scale division just before Vernier 0? That seems to be 14. So this is 14 millimeter. 14 millimeter mark. Try to take readings in millimeters. Later on you can convert them into centimeters. And just before Vernier 0, the reading is 14 millimeter plus. Then you have to see the coinciding Vernier division with a main division. What is the coinciding Vernier division with a main division? 5th one. But actually it's labeled as 10. That's the 5th one. Did you see that? Right? 1, 2, 3, 4, 5. It's the 5th one. 5th one is labeled as 10. Okay? 5 into 0.1. So that gives us 14.5 millimeter. I need it in centimeters. So it's 1.45 centimeters. That is answer number 3. Right. We come to second question. An elastic string has length of 30 centimeter when tension is 3 Newton. So 3 Newton, length is 30 centimeter. When tension is 4 Newton, length becomes 32 centimeter. So when this is 4 Newton, second question, length is going to be 32 centimeter. Now my question is, when tension increases to 7 Newton, length of the string will be. Pute, can you see here to here, what is the force increment? 1 Newton. What is the corresponding length increment? 2 centimeter. We know force is proportional to x. And delta F will be proportional then delta x. Increase of force proportional, increase of extension, increase of length. And next moment we are going to have how much? 7 Newton. Now see here, 4 to 7, what is the force increment? How much? 3 Newton. And at 1 Newton if it is 2 cm, 1 Newton if it is 2 cm, to 3 Newton what should it be? 6 centimeter. 6 centimeter. So what is the value we are going to have? 32 plus 6, 38 centimeter. Your answer is answer number 2, 38 centimeter. Put our question number 3 now. Third question. Energy E of a photon of frequency f is given by E equal hf. E equal hf. Dimensions of h. Put a energy equal h into frequency. Energy is what? ml square t minus 2. H into frequency is what? T minus 1. So h becomes equal to ml square t minus 1. This is your answer. That's answer number 1. Question number 4 now. Fourth one tells a small mass is kept on a horizontal circular table which can rotate about a vertical axis passing through center of the table. Mass starts to slip when angular velocity of the table becomes omega. If distance to the mass from center of the table is doubled, minimum angular velocity required for mass to start slipping is. So this is our disk. When distance is r, angular velocity is omega, mass start to slip. What I am asking is, if we double the distance, that's going to be how much? 2r. What is the angular velocity with which it will slip? Pute, what is the force for the circular motion? Centripetal force, what is it? Friction. Friction is what? Mu r. Mu r is same in both moments. Mu doesn't change, same table, same object. R doesn't change, mg same. And now don't forget, centripetal force is the same. Centripetal force is same, so centripetal force is what? R omega square. So centripetal force, centripetal force is the same in both moments. Why? Because, let me explain Venalian. Because frictional force, limiting friction, limiting frictional force is the same. So here to this one, r omega square, mr omega square, mr omega square. Acceleration is r omega, friction is mr omega square. And m r omega square equals same as radius 2r into omega dash square. So mr cancel, omega square equal 2 omega dash square. Clear? I can take square root. When you take square root, omega equal root 2 omega dash. Omega dash equal omega over root 2. That is answer number 1. First answer, I just explained, okay? And again question number 5. Figure shows displacement time graph for motion of two cars with respect to the lamp post aside the road. Consider the displacement of the right side of the lamp post as positive. A student has made following statements regarding motion of the car relevant to the points P, Q and R marked on the graph. A. Relevant to P. P is a point, Darwane. relevant to P. Clear? Relevant to P. What is the point P here? Point P means the position where car A has displacement 0. So at that moment this car 1 comes to this post. Can you understand? පැහැදිලිද මේ කියන දේ? ඒව නේද මේක කියන්නේ? Right? So displacement comes to at the point P. At the point P. P is a time period. Okay, puta? P is a time period. Puta. Here time, no? Time axis. P is a time period. P is the time where car 1 comes to this post. QR is the time where, right, car 2 make displacement 0. When time is P, this car comes to this position. When time is R, this car comes to this position. When time is Q, what is happening? They are going to meet. ඒකයි වෙන්න ඕනද? පැහැදිලිද? Right. එහෙනම් relevant to P. Car 1 coming from left crosses car 2. No. මෙතනෙම cross වීමක් කරන්නේ. Can you understand? මේ time එකේ cross වෙනවද? කොයිලද cross වෙන්නේ පුතා? Here. Q කියන point එකේනේ. Can you understand? Q point. They have same displacement. එහෙනම් පුතා statement A is wrong. B relevant to Q. Yeah, yes. Both cars moves towards the post. ඒ කියන්නේ මොකද කියන්නේ? Relevant to Q. Both cars move towards the post. හරිද වැරදිද? හරිද වැරදිද? වැරදි. ඇයි? Q තමයි පුතේ the moment they are going to meet. They are going to meet. හැබැයි පුතේ Q කියන තැනදී where is the car 1? Car 1 එක ඉන්නේ in the right side. Where is the car 2? Car 2 is also in the right side. එතකොට ඔය Q කියන point එකේදී car දෙක මෙහෙම තියෙන්නේ. car දෙක මෙහෙම එක තැන මම මෙහෙම අඳින්නකො. මෙන්න vehicles දෙක තියෙන්නේ. Right. Car 1 is moving to the right side, C1. Car 2 is moving to the left side. Okay. So car 2 is moving to left. At that moment they meet. At that moment when they meet, are they moving towards the post? No. This is moving toward the post. Right? So only C2 is moving towards the post when they meet. When they meet, only C2 is moving towards the post. C1 is moving away from the post. Statement B is wrong. C becomes automatically correct now, right? Relevant to point, relevant to R. R. Car 2 coming from right. Yes, car 2 coming from right passes the lamp post. That's true. That's the point where displacement becomes 0. At the point R, R is a time period. Displacement of car 2 becomes 0 means car 2 comes to this post. Correct, Puta. Answer is only C. Second answer. Put on now question number 6. It tells a small object is placed inside a right circular cone with axis vertical and vertex down as shown in the figure. Coefficient of static friction between the inner surface and the cone and object is mu. What is the maximum angular velocity of the rotation of the cone about its axis for the object to be on the inner surface of the cone without slipping distance d away from the axis? හරිද? So that's moving without a slipping කියලා කියන්නේ. What is the maximum angular velocity of rotation of the cone? Right about axis for object to be on the inner surface of the cone. So it's a circular motion object. This is the cone. Here is that object. Right. Puta, the circle is a horizontal one. It's a circular motion. Let's label forces. Weight, mg, normal reaction, what is it? R. This angle is theta. You have even friction. When it has maximum velocity, clear? Then make a kiyanne maximum velocity. Right? මොකද කියන්නේ මෙයාගේ motion එක? This is trying to fly away, so friction is along. And what is its value? Mu r. Mu r. F dash equal mu r. Can you understand what I wrote here? It's mu r. Ena පුතා, when this is theta, හොඳින් බලන්න. Here is the center, I draw a horizontal line. Theta, here 90, 90 minus theta, what is this angle? Make a key. This is going to be theta. Pute, when circle is horizontal, circle is horizontal always, vertical forces are balanced. Enandaruwane horizontal circle ekak, vertical forces are balanced. Vertical force R udata, R what? R sin theta up. R sin theta up is equal to mg. R sin theta equal, sorry, we have another one. Mu r wali venema. R sin theta equal mg plus mu r cos theta. This theta, this is also theta. Right? Mg plus mu r cos theta. I can take that to the left side. R sin theta minus mu r cos theta equal mg. Then I can apply F equal ma towards center. What is the force towards center? R cos theta. R cos theta equal mr omega square. පුතේ r cos theta විතර දෙන්නේ. R cos theta plus mu r sin theta වෙනවා. එහෙනම් මෙතන දරුවනේ centripetal force is r cos theta mu r sin theta. R cos theta plus mu r sin theta equal mr omega square. Now I can divide these two. Number 1, number 2. I'm dividing. 2 divided by 1. It gives us r veliyatagam cos theta plus mu sin theta divided by again r veliyatagama puta sin theta minus mu cos theta equal r omega square over g. So this part comes to the left, g cos theta minus mu sin theta divided by r sin theta minus mu cos theta equal omega square. So omega equal root g cos theta minus mu sin theta divided by r sin theta. Right, 1 is going to be plus here, this plus, minus mu cos theta. What is answer number, Pute? Cos theta plus mu sin theta. Answer number 1, right? What is the answer number? Kyanaka Putala? Third answer. Pute, instead of R, it's given as D, ne? Third answer. Third answer. Okay. Uda, question number 7. Motion of an insect living on sand generates transverse wave traveling at 50 meter per second and longitudinal waves traveling at 150 meter per second along sand surface. A scorpion can estimate location of insect from the difference delta t in the arrival times of these waves. Delta t is 4 × 10⁻³ distance from scorpion to the insect is. So there are two waves. Transverse wave travel with velocity 50 and there's another longitudinal wave that travel with velocity 150. Now, right, these waves are going to travel between two locations. Just think, at the same moment, right, two vehicles are starting to move again. At the same moment, one has velocity 150, other one has velocity 50. Which comes to that point quickly? That one, it goes fast because it's velocity 150. So it goes fast, the other one will be still, right, somewhere between those two. My question is, the distance between these two, S, x anyway, delta t is given. What is delta t? Time gap. Time gap. So let's consider time for L wave equal t. Then tell me what is the time, then what is the time for T wave? T plus delta t. It takes more time than that. The time gap is given. Now write S equal ut. So S is x, velocity 150 time taken t. Clear? This gives t equal x over 150. Now I apply S equal ut, right? This was applied to L. L means longitudinal waves. Now I apply to transverse wave. When you apply to transverse wave, S is x, velocity 50, time is what? T plus delta t, which is equal to, delta t is equal to 4 × 10⁻³ So x equal 50t minus 200 × 10⁻³. Okay. Now here, what is my question? What I am asking is x value. So x equal 50 into t. What is t? X over 150 minus, this gives us 0.2. 0.2. Then these two get cancelled. It is 3. So you can take this to the left side. X minus x over 3 equal 0.2. So 2x over 3 equal 0.2. X equal 0.3 meters. We got the answer. 0.3 meters. Answer number 4. Puta, question number 8. A ring, a disc, a sphere, all of the same mass and radius, with moments of inertia IR, ID, IS respectively about the axis, roll down without slipping on an inclined plane from a given height. If the times taken for ring, disc, sphere to reach bottom of the plate is TR, TD, TS respectively, then Puta, question number 8. 3 objects are going to roll down. When these objects roll down, they have to move down same height. They have same mass. And gravitational potential decrease is the same. Finally, that gravitational potential convert into rotational kinetic energy and translational kinetic energy. So here mgh equal half mv square plus half I omega square. Darwane, if you consider, right, I'm writing it here, mgh equal half I omega square plus half mv square. So to all the objects mgh is the same. Let's consider moment of inertia. Which has highest moment of inertia? Ring. For ring, I is greatest. I is greatest. When I become greater, in the right sign, then what should happen to omega? What should happen to V? Left side is same for all the objects. If left side is same for all the objects, right side should also be the same for all objects. But I is greater to ring. And omega is lower to ring. V is lower to ring. When I is greater, at the left side is same, V is lower to the ring. Velocity lower to the ring means it comes to the bottom, right, slowly. It takes more time. Which will come to the bottom quickly, which will come to the bottom at the end? The ring, because it has lowest velocity. I'm asking about the time periods. Ring will come last. Time for ring is the greatest. Then, what should it be? So, it should be S time to the sphere, then time to the disk, because it becomes the opposite, no? Right. So, answer is TS is the TR is the greater. What is the answer here? The correct one? Third answer, it's given in the other way. TR, time to the ring is greatest, then time to the disk, time to the sphere is the lowest. Statement all the 3 bodies have same gravitational potential energy. All the 3 bodies have same gravitational potential energy. All the 3 bodies have same gravitational potential energy. But I is greatest to ring. But I is greatest to ring. So, V is lowest to ring. So, V is lowest to ring. It means ring takes greatest time. Ring takes greatest time. Now you can note whatever you need. Okay, Buddha. Now question number 9. Number 9 tells two measures capital M and simple M placed on the frictionless surface and connected together as shown in the figure using a spring whose mass is negligible. Two measures. First, pressed together so that spring is compressed and then released. If initial acceleration of mass simple M is A, what would be the magnitude of acceleration of capital M at that one? Daruvane, what is the concept here? Same force is applying on each object. And Amputa, you can take in question number 9, F equal MA. So force on simple M F now, even on the other one you should have same force, right? So the concept is both objects feel same force. Write that sentence, Pute. Both objects feel same force. Both objects feel same force. Both objects feel same force. So now you can write F equal MA, and to the other object same force but a different mass, so different acceleration, MA dash. And MA dash equal simple MA. A dash equal MA divided by capital M. Putha, now number 10. Question number 10 tells a piece of metal is attached. So, top of the rectangular wooden block that floats in water as shown in the figure. 50% of volume of wooden block is submerged in water. Metal piece and block have same mass. If wooden block with the metal piece is flipped upside down, what could be the percentage of the volume of wooden block submerged in water? Very simple. Putha, if this has mass M, this also has same mass. At this moment, by immersing exactly half of wooden block, 2 mg is balancing. Second moment also 2 mg should be balanced, but this time what is happening? This time object, this is also immersed, right? So do we need to immerse 50% of the block, or is it less than that? No, it's less than that. With the same mass, same total mass, and the same upthrust should be given. To give the same upthrust, less than 50 should be immersed, because here now this metal piece is also immersed. So the correct answer is what? Slightly lesser than 50%, answer number 1. Right? You better note like this. In both cases, upthrust is the same. In both cases, upthrust is the same. In both cases, upthrust is the same. As the metal piece is immersed in second situation, as the metal piece is immersed in the second situation, volume of the wooden immerse is less than 50%. Less than 50%.